Osama, you will start the first one. I will start the names from here. Osama will start the first question. Read it.
Yes, mister. The SI unit force is?
Yes.
Just give me a second, mister.
Take a second.
Mister, will you send this WhatsApp?
I'll send the video on Coursera, not the worksheet.
السلام عليكم ورحمة الله وبركاته.
عليكم السلام ورحمة الله وبركاته. So focus with me here.
It's Newton.
It's what?
Newton.
Newton D. Answer D. Yes. So
Mr.
I will...
Question.
Yes, go ahead.
Do you have tomorrow test?
Yes, you have.
Okay.
We have revision today.
What about the project?
Start lessons what and what and what.
Chapter 12, lesson 1, 2, and 3.
Okay, do you have the sheets?
No sheet. You will take only the quiz, the video. I will upload it into Coursera, and I may send you some quizzes on that.
Okay, Mr. Can you send the file of the worksheet you have now?
No, I can't because it's a big file. If you want it, it will be a very big file for you and a lot of other questions that you don't need it. It's not only for what we are having for the quiz.
So we don't need it.
Yes, we will focus on our revision here right now. Abbas?
Mister, what about the project?
Later, not right now. Tomorrow or after tomorrow, you can ask about the project. We have revision today.
Okay.
Abbas absent. Abdelmajid Farouda. Abdelmajid. Abdelhadi. Abdullah Abdelbaqi.
Yes, Mister.
Okay, Abdullah. Read the second question here.
Which the following relationships is correct? Which is D.
D. 1 Newton equal 1 kilogram times meter per second square. Bravo.
Mister, wait, I have a question. Excuse me, mister.
Yes, what's the question?
Can you make this send it for us?
I will send the video for what we are doing right now to Coursera after the session.
The worksheet, I mean.
No, not the worksheet. I will send. I may send the worksheet, but it's blended with other questions. It's not only for chapter 12, 1, 2, and 3. It have other questions. So if you have it, you will answer or you will study other questions that you don't need it. But I may send it. It's no problem for me. When an unbalanced forces acts on an object, this is would be Abdullah Abdulatif.
Here.
Okay, Abdullah. Question 3, read it.
When a non-balanced force acts on an object, A, the object's motion does not change, B, the object accelerates, C, the weight of the object decreases, and D, the inertia of the object decreases. Is it B?
The object accelerates, yes, because acceleration is related to unbalanced force. The answer is B. Bravo, thank you. Abdullah Abdulatif. Abdullah Dehilan.
Yes, Mr. Here, Mr.
Okay, question 4, read it.
When a pair of balanced forces acts on an object, the net force that results is greater in size than both forces combined, greater in size than one force of the forces, equal in size to one of the forces, equal to 0. I think, Mr., it is equal to 0.
Yes, it's equal to 0 because they are balanced. Balanced force. And balanced mean net force equal to 0. Thank you, Abdullah. Abdullah Mubarak. Abdullah Mubarak.
Yes, Mr.
Abdullah, would you answer the question 5? Question number 5.
What kind of friction occurs as a fish swims through water? Fluid.
Fluid, bravo. Yes, fluid. Thank you, Abdullah. Abdurrahim. Abdurrahim Adil. So Abdurrahim absent. Abdelhadi absent. Abdelmajid absent. Abbas absent.
Mr. Abdelhadi is here.
Huh?
I am here, Abdelhadi. Yeah.
I called your name.
And they said,
Okay, Abdulhadi, read this question and answer it. Question 6.
as you push serial books across tabletop, the sliding friction action of the serial books C, I think.
It's usually greater than the static friction. Yes, it's always sliding greater, not greater. Sliding is not greater than the static. Read all of them, Abdulhadi, and choose the right one. Which one is the right one? Abdulhadi.
Yeah, Mr. A, acts in the direction of motion.
This is the answer. The friction force acts in the direction of motion, Abdulhadi?
No, in the opposite, I think.
In the opposite direction of motion. So the answer is D. Abdulhadi, the answer is D. Acts in the opposite direction of motion. That's it. The answer D. Thank you, Abdulhadi. We still have Abdulmajid absent. Abbas. Abdulmajid and Abbas.
No, Mr. I'm here.
Who? Abbas?
Yes.
Okay, Abbas. Read question 7.
The forces acting on a fallen leaf are.
The forces acting on a falling leaf are.
Gravity and air resistance.
What?
B.
Which one? B. Gravity and air. Yes, gravity and air resistance. The answer is B. Thank you, Abbas. Abdulmajid is here. Abdulmajid is not here. Abdulrahim. Abdulrahim Adil. Adham.
Here, Mr.
Adham. Okay, Adham. Question 8. Read it.
An open parachute increases air resistance of a falling skydiver by.
Yes. An open parachute increases air resistance of a falling skydiver by what?
I think it's C.
C, increasing the terminal velocity. An open parachute increases air resistance. Yes, falling by increasing the terminal. No, not increasing. Not increasing air in the terminal velocity. No, not C. By what? Read all the question, all the choices, Adam.
Decreasing the weight of the diver, increasing surface area, increasing the terminal velocity, reducing flood friction.
What is the right answer?
A.
How to increase the resistance when someone is falling from a plane, diving in the sky, falling toward the earth. What may increase the air resistance? Upward, not downward. Yes, increasing surface area. So the answer is B, increasing surface area. This is the answer. Let me check. We started. Yes, we started. Thank you, Adam. Ahmed Al-Gannas. Ahmed Mut'ab. Ahmed Mut'ab Al-Gannas.
Yes, Mr.
Ahmed, read question 9.
Figure 1 to 12 shows the motion of 3 balls. The curved paths followed by ball B and C are examples.
The curved paths followed by the balls B and C. B and C represent what? Centripetal motion, constant, linear, projectile motion. Yes, I hear you, but you have, sound is not clear. So what's the answer?
B.
V, constant motion? No, not constant motion. When you have a curved path for something that is falling like this, that means it's combined effect by gravity downward and constant velocity horizontal in this direction. And this kind of motion, what we call it? When you have a curved path like this one, what we call it, Ahmed? No, we call it projectile motion, D, Ahmed. We call it projectile motion, D. Okay, Ahmed, the answer is D. These paths are called projectile motion. That's it. Projectile motion caused by, I've just answered that question. Ali Yusuf Al-Hilal. Ali Yusuf Al-Hilal.
Yes, Mr.
Answer question 10.
Projectile motion is caused by...
Yes, projectile motion is caused by what?
في ازعاج أستاذ.
Huh?
في ازعاج.
You mean other sounds is working at the same time?
Yes.
Some other student open the mics. Just 1 minute.
Yes, Mr. الصوت من عندك.
If you mean the sound coming from outside, this is for some mosques are calling for prayer. It's not from house, it's from outside. They ended right now. So answer this question. Who is the next one? Or who's telling me this? Ali Hilal. Ali.
Yes.
Question 10. Read question 10.
Projectile motion is caused by, I think, Mr. B.
Only B, an initial forward velocity. No, there are two things involved in projectile motion.
D.
D, yes, D. The downward force
of gravity and initial forward velocity.
Yes. Is it still noisy for you guys, or it's clear right now?
No, it's clear right now.
It's okay. It was from outside. So let's go for the next one. Faisal is here or excused? I think that he's excused. Faisal, excused. طيب Hassan Ramadan.
Yes, Mr.
Hassan, can you read this question? Question 11.
The property of matter that resists change in motion is called. I understand.
The property of matter that resists changes in motion is called what? What did you say?
Inertia.
Yes, inertia. Inertia, yes. Inertia is the property of matter that resists change in motion. Question 12. Ibrahim is excused over here. Ibrahim Adil. Excused. Ibrahim Anwar.
I'm here.
Okay, Ibrahim Anwar. Question 12, read it.
An orange might roll off your cafeteria tray when you stop suddenly because of A, the balance force acting on the orange, B, the centripetal force acting on the orange, C, friction force acting on the orange, D, the orange inertia. The orange inertia.
Bravo. D. Because you stop suddenly, so the orange continues to move forward with the same original speed, That's because of orange's inertia. Thank you, Ibrahim. Ibrahim Rabia? Ibrahim Rabia?
He will go and come back, Mister.
No, I'm here, teacher. I'm here.
Okay, Ibrahim, read question 13.
Okay. According to Newton's second law of motion, the acceleration of an object equals the net force acting on the object divided by the object's momentum.
According to Newton's second law of motion, the acceleration, no, not momentum, equal to the force divided by what? Force divided by what equal acceleration? Velocity? No. Force divided by, you have it here. Let me just move downward, that's it. If you want acceleration, you divide force divided by what? What is this?
Mass.
Mass, yes. Net force divided by mass. So the answer is mass. You divide force by mass. The answer is A. Thank you, Ibrahim. Yeah. Muaz.
Yes, Mister.
Muaz, would you answer question 14?
If a force of 12 Newton is applied to an object with a mass of 2 kilograms, the object will accelerate at 24 miles per second.
So you have to divide force by mass to get acceleration. So the answer would be? You need the acceleration.
Yes.
So
I thought that
6.
you want something else.
Yes. So 12, the force, this is the same rule here. Defines acceleration, force divided by mass. Force is, the net force is 12, the mass is 2. So the acceleration is 6 meters per second square. Question 15. Muammal.
Yes.
Read question 15.
Your weight equals your C, mass times the acceleration due to gravity.
So your weight equals your mass times acceleration due to gravity. Yes, that's right. So the answer is C. 16. Thank you, Muhammad. Muhammad Abdul Baqi.
Yes, Mister.
Question 16, Muhammad.
The acceleration due to gravity on the surface of Mars is about 1/3 the acceleration due to gravity on Earth's surface. The weight of space above the surface of Mars is about 1/3 its weight on Earth's surface.
1/3 its weight?
Yes.
The answer is C. The answer is C. Okay, yes, 1/3. So to 1/6. So it's 1/3. The answer is C. So because what? Because the acceleration is directly proportional to force or the weight. So if the acceleration, acceleration due to gravity decreases to 1/3, that means, let me type it for you. Here. You have weight equal mass multiplied by gravity acceleration. So if gravity acceleration is decreased by 1/3, multiplied by 3, 1/3, so that will apply to what? Directly to the weight. The weight will decrease by the same ratio. So the weight will decrease to 1/3. That's the answer. So the answer here is 1/3 its weight on Earth's surface. Thank you, Muhammad Abdul Qadir. 17. Yes.
How do we study for the test tomorrow?
From this, right now we are studying. Not worksheet. For the video, I can send you the worksheet. Maybe I will send it to you. Then you can study from both of them. Okay? I may send you the worksheet. So, Muhammad Ayman. Muhammad Ayman is here. Muhammad Ahmed Ramadan.
Yes, Mister.
Okay. محمد أمين Milham is absent. طيب محمد رمضان answers question 17.
Newton's third law of motion describes action and reaction forces.
Yes, Newton's third law of motion describes action and reaction forces. Thank you. So the answer is A. 18.
Muhammad Saad. Yes, here, Mister. Here, Mister.
Okay, Muhammad. Muhammad, question 18.
In which of the following are action and reaction forces involved?
Yes.
Mister, I think it's all of the above.
In which of the following are action and reaction forces involved?
No.
When a tennis ball attracts a tennis ball.
A, Mr. A.
When a stepping from a car, when rowing a boat. So it's not all of them. No, not all of them. When tennis racket strikes a tennis ball, that's action reaction force.
Yes, it's
because yes. Let me continue with you one by one. Taken case by case. When a tennis racket strikes a tennis ball, the tennis racket acts on the ball by force, and the ball acts on the racket by equal and opposite force, action reaction. When stepping from a curb or a curve, this one is also action and reaction. When you walk, for example, the earth or the ground pushes you forward and you push the ground backward. It's also action reaction force. When rowing a boat, when you row a boat, the pedal that you use it is acting on the water backward and the water acting on it forward. So it's also action reaction force. So all of these are examples of action reaction force. To understand what's action reaction force, it must include two objects, not only one object. And the two objects are acting on one another, no matter the relative masses or the relative volumes of these two objects, but they will act on one another, and that will be directly an action reaction pair. So all of these examples, we have two objects acting on each other. So all of these are action reaction forces. So the answer is all of the above. Question 19. مرتضى أو عبد العزيز الهلال. عبد العزيز الهلال.
Yes, Mister.
19.
The product of an object's mass and velocity is momentum.
The product of an object's mass and velocity is its momentum. Yes, bravo. Answer B. 20. Navjan. Saad Al-Yami.
Yes, Mister.
Saad, answer question 20.
What is conserved when two objects collide in a closed system?
What is conserved when two objects collide in a closed system? What's conserved? Acceleration is conserved, momentum, speed, velocity. When you have a closed system, and the closed means no forces acting from outside and no mass are added or removed from the system.
Velocity?
No. Velocity is not conserved. During collision, the two balls or the two cars or the two objects may go in a different direction and with different speed. So velocity is not conserved during collisions.
So it's C, Mister.
Was acceleration, velocity, speed, but it's not all of this. It's a momentum. Momentum, which equals mass multiplied velocity, is conserved during collisions if you have a closed system. This is the condition to have momentum conserved. We have the condition here. He told you that it's a closed system, so momentum is conserved during collision, and that means the momentum for the whole system before and after collisions is the same. That was the lesson of yesterday. Did you attend with us yesterday, Saad? You didn't. Saad Khalid Al-Husseini.
Yes.
So answer this question. 21.
I read the answer. No.
Read the question and answer it.
What is the momentum of a 50 kilogram ice skater gliding across the ice and at a speed of 5 ms?
Meter per second, yes. How to find the momentum? What is the rule to find the momentum? What is the formula to find the momentum? Also yesterday, listen.
Kilogram or speed.
No.
Why?
No.
Why to multiply?
What? What?
Why to multiply speed? Wait.
Momentum, you read this one. Momentum from yesterday equal mass multiply velocity. It's a vector quantity. It has the same direction as the direction of velocity. And its units is kilogram times meter per second. No shorthand for it. This is momentum. So if I want to calculate momentum for something or for one object, I only have to multiply mass to multiply mass by velocity. So what the answer here? Question 21. Do you know the answer? You have mass and you have velocity, or the speed. What he asking about the momentum? How to find the momentum? Saad al-Husseini.
Yes.
Saad al-Husseini. How to find the momentum?
Mass multiply velocity.
So, what is the momentum here in this question? What is the answer for this one?
D.
What's the answer for this question? Huh?
D.
D, yes. You multiply 5 by 50 equal to 150 kilogram meter per second. Again, that's it. Momentum equal mass multiply velocity. Mass is 5, velocity is 5, and the mass is 50. So 5 multiply 50 to 150, and the units are kilogram meter per second. So the answer is D. So this question is not involved with us until 30. This is for the third lesson. We have some completion here. We don't need it either. Then we'll go to these problems to solve it. Let me choose someone. Ali Marzouk, Ali Kamal.
Yes.
Ali, read this question. Question 51.
A tow truck exerts a net horizontal force of 1050 N on
What is the acceleration of the car due to this time? Show your work. Let me take this one. I'll stop I'll share in a minute. I'll take the question here. And let me put here into the board. Then I will share with you this. So that's it. Sorry. Let me enlarge it so you can read it. So a tow truck exerts a net force of, let me see it again here, bring it to you. 1050 Newton, and 760 kilogram. 700 kilogram on a mass of 760 kilogram car. What is the acceleration? Can you find the acceleration? Ali? Ali, can you find the acceleration? Ali Marzouk.
Yes.
Can you find the acceleration? What is the rule to find the acceleration? Acceleration equal what? What is the rule for finding acceleration, Ali? Huh?
I don't know.
Why? Why you don't know? You take it? It's equal net force, Ali. We just take it today. Net force, we talk about it today. Divided by mass. If you go up here, this is where we record our lessons. You'll find that force equal mass multiplied acceleration. It's Newton's second law. If you want to find acceleration, equal force or net force divided by mass. Okay, Ali? So if we come here and go down there and ask you to find the acceleration, all you have to do to divide net force by mass. What's the net force, Ali?
Give me a second.
Yes. What is the answer?
1.3.
1.3. 3. What are the units? What are units for this one? Acceleration units. Meter per what?
Per
second or second square? Per second square, Ali. Acceleration units are meter per second square. Okay. So acceleration units are meter per second square. Okay. Thank you, Ali. Next question. For somebody else. Navjan absent. Muhammad Daim al-Milham absent. Faisal excused. Ibrahim Adil. Ali bin Saad. Abdurrahim Adil absent. Abdurrahim Adil. Abdul Majid Farhouda absent. Let me pick randomly some of you, and that will be Muhammad. Muhammad. Muhammad.
Yes.
Can you read this question and answer it?
The mass of a newborn baby is 3.5 kilograms. What is the baby's weight? The acceleration due to gravity at Earth's surface is 9.8 meters per second. Show your work.
Yes. What is the weight of 3.5 kilogram? Baby is 3.5 kilogram. What is the weight of this baby? How to find weight?
Mass multiply the acceleration due to gravity.
Weight W equal mass multiplied by gravity acceleration. So it will equal to math 3.5. This is the weight of the mass of the kid, of the baby. 9.8. What is the answer?
0.8.
What will be the answer?
Calculate this.
Calculate it and tell me the answer.
$34.3.
34.3. What are the units of
Kilogram
weight?
Multiply.
Weight. Yeah. Kilogram multiplied what?
meter per second square.
No, this is, oh yes, kilogram, you can say that from here, you will take it from here. It's a Newton, weight is measured in Newton. Because it's a force, weight is a force, force downward. Force downward. Okay, this is weight, is a force downward.
Okay, or Newton.
Or equal to, from here, as you said, it's right, not wrong, kilogram, because Newton equal to that. Kilogram times meter per second square. Short-handed as Newton. Short-handed as Newton. So thank you guys for listening. Tomorrow, inshallah, we will take quiz on that. I will send you the video on the session right now, and also send you some problem that we have solved it from that lesson, so you can study it. Thank you for listening.
Mr.
Yes,
Will we have the revision sheet?
I may send you one. Yes.